Professor Iluka.
And I'm Professor Santella.
Today on our second video, we're going to speak to you about hybridization, how it works, how it's done, for a couple of examples using molecules that have sigma bonds and others that have pi bonds. So our first example is going to be with methane, CH4. So here our second example is going to be C2H4. Our third example is going to be with C2H2. Last but not least, we're going to do with N2, nitrogen. Okay, so now we're going to do the hybridization of CH4. So we're going to start with the Lewis structure. Here we have 4 H's on the C. So now we're going to do the configuration for the valence electrons of C, which you learned in your chemistry classes. And we're going to do the box diagram. So we have the S orbital and the P orbital. In the S orbital we have 2 electrons. In the P orbital we only have 2. So here you can see that there are 4 bonds on the carbon by looking at the Lewis diagram. But here we have 1 bond, which symbolizes that there's a lone pair. However, this is not the case, as we can see through the Lewis diagram. So in order to be able to make 4 bonds, we're going to have to promote an electron so it can into the p orbital, so we have another electron in here which is able to make a bond with another hydrogen. So we're going to take this bond, move it over in here. So our final result, we have three electrons, so we can make 4 bonds with the H. So the final, call this the excited state of C. So our final hybridized, we combine both the S and the P orbitals together. Total of 4 boxes, so we just simply add the boxes and we put our 4 electrons inside. And since we have 3 P orbitals, 3 P boxes, 3 in the P orbital that are participating, we'll put P3, and there's only 1 box in the S, so it's only S. So the final hybridized state is sp3.
Okay, so we have our 1s orbital here and the 2p3 orbital here, and we have the 1s orbital filled with 2 electrons. Okay, and another electron in the 2py orbital, and there's no electron in the 2pz orbital. So now, for C hybridized, what you want to do is, since we have a double bond, since we have a electron pair here, we're going to move this into the other orbital so that we can get our 4 bonds here. So we're going to move this in here and get a new set of orbital box diagrams, all with 1 lone electron inside, and the 1s, 2p x, 2p y, and 2p z. So now that we've moved the molecule over to the 2p3 orbital box, we can name the new C hybridized box, combine them here, and we have a lone pair in each box, and this will be called an sp2 C hybridized, because you have 1 S and 2 P's here. The last electron used, we can separate it, it's known as the pi bond, because it will be used to satisfy the second bond between the 2 C's, and the other 3 will be used for this bond, and that bond. So this is how to hybridize a C2H4 molecule. So now we'll draw the orbital box diagram. And here we have the 1s orbital, and here we have the 2p orbitals. And in the 1s orbital, you have, based on the periodic table, you have an electron pointing up, pointing down, and then you have 3 lone electrons here. And now to hybridize this, so this is regular, and to get n hybridized, what we're going to have to see here is that these correspond to the lone pairs here, whereas this one corresponds to one of the bonds here. Now, if we separate these are both pi bonds that correspond to the two bonds there, the pi bonds. So now, if we do n hybridized, we would put these together to get sp, because we're using the s orbital and one in the p orbital, and these two are being used as pi bonds. And this is your final answer for nitrogen hybrid for N2 hybridized.